Hi, my name's Evan McCorkle. I'm a developer with Jump, and I'm here today to talk about a add-in that I developed using the Jump 18 new Python integration. This add-in is for physical unit conversion, and I'm going to go over why I developed this add-in, as well as how I developed this add-in and kind of the techniques that I used in developing it, and some of the details about the Jump 18 Python integration used there as well. So my training and my early career were as an engineer. And in that training and in that early career, I had to deal a lot with different unit systems and different kinds of units, mostly US customary units and metric units. I'm sure many of you have to do this as well. And I'm sure many of you know that there have been many high profile, costly mistakes due to unit conversion problems. And for that reason, I always tried to use a tool to help me check my unit conversions. And oftentimes I use a Python library called Pint to do that. And I was looking at the new Jump 18 Python integration, and I wanted to see, could we put that in with Jump's existing capability of annotating columns with their units. So if you go to a column, you can put a unit on that column. And can we use that to do unit conversions and validate the units and all that sort of thing? So that was kind of the impetus behind developing this add-in. So the add-in's capabilities, when you bring in a table, it can detect parenthetical units on columns and auto-assign the unit property and validate those units. It can let you look at a glance at your whole table and the units for the whole table, make bulk changes to units, make sure that the system understands the units and the abbreviations that are being used, as well as determine the units for simple formula columns. And then the main powerhouse of the add-in is converting columns between units. So converting from inches to millimeters, for instance. And you can either do this in place or as a new column. And when you convert the data, it will also convert over the column properties as well, like your reference lines, your axis settings, your spec limits, et cetera, et cetera, et cetera. In addition to these capabilities, there's a browsable database of all the supported units and the ways that you can compose the units, as well as a JSL API. And if you're interested in any of this, you can see the QR code on the screen here, or you can go to the community and look for the unit conversion add-in. So now that's all I'm going to talk about, the features of the add-in. So now I'm going to talk about how the add-in was developed. So for source control for the add-in, I used Git and an internal GitLab instance. For building and deploying the add-in, I used the custom solution of a build add-in JSL file and a manifest JSL file, which I'll go into more detail in a minute. For testing, I used the JSL Hamcrest framework. So you can find that on GitHub. I'm a co-developer of that framework. We use that framework internally within Jump to test Jump itself, and I used it to test this add-in as well. For documentation, mostly markdown files that are then converted to HTML using Pandoc and put into the add-in and then shown in the add-in using the Jump built-in web browser. Everything's implemented via JSL and Python with the Pint library in Python. And then other tools, Jump, VS Code, Git, Pandoc, and Google material icons were used in this. So the structure of the add-in at the top level kind of looks like this. You've got a build folder, docs, source, tests, and then kind of the README markdown files. So the tests are kind of separate off on their own. The build has the build add-in and the manifest file. and the artifacts subfolder, which is where like the HTML goes and where the jump add-in itself will go when it is built. Docs are mostly screenshots and things like that. And then the source folder has several subfolders, icons, menu. So the menu has these action JSL files in it that are very, very simple. They're just used by the jump cust file as kind of a jumping off point, as well as source, which is kind of the bulk of the code. And then we have the def, jump cust, and the add-in load JSL file. So for the manifest file, this is basically a listing of all the files from this structure over here on the left that it's going to end up in the jump add-in archive that will then be installed. And the build add-in JSL script basically does the pandoc step to convert Markdown to HTML, reads the manifest, and uses the JSL zip archive API to collect all the files and put them into a jump add-in file in the build artifacts directory. So anytime I wanted to add a new feature, I would go put an icon in source icons. I go put a short little stub code in source menu, and then the bulk of the code would go in source. Take all three of those files, add them to the manifest, edit the jump add-in cust file to refer to that little stub in source menu, and then I could build the add-in and start developing on that feature, and then add tests to the suite in the test files. So the stub in source menu would just do some basic validation, like look for a current data table or something like that. And then it would include the main source file and then invoke the GUI. And the reason for this separation is so we could easily include this main source file in the test and then test that feature without invoking the GUI. So it's just kind of a nice division between the source menu, which is what's invoked interactively when you click on the menu, and the test files, and they both run through source. And now finally, since a big part of this add-in is using the new Jump 18 Python integration, I wanted to go in detail about how that works. So that basically consists of three parts. First, in the add-in load file, whenever the add-in is loaded, we go try to install the Python packages. So Pyth is one of them. Install that, make sure it's installed. And then I have a com jump unit conversion py file that is installed with the add-in. And I go ahead and import that as this, this fully qualified name here. And basically everything that's in that Python file is just a bunch of function definitions. And they all use the Pyth library. But there's no real work, it's just the function definitions. And then in the core JSL code, I wrap those Python calls using that fully qualified name and the Python integration inside of a JSL function. And then in the rest of the add-in, I can just use the JSL functions over here on the right. Are units convertible? Feet to kilometers? Yes. Feet to milliliters? No. And it's just using regular JSL functions, but internally those are going into the Python code using the Python integration. Everything is set up on the add-in load, and all of my Python code is nice and contained inside of this one package, so I'm not polluting kind of the whole Python namespace. So that is how I used the new in Jump 18 Python integration to develop this physical unit conversion add-in. Thank you.